Chapter 1, Rate of Reaction, Class Life Science. Part 4, Half-life time and shape of curve. At the end of this session, students should be able to determine graphically the half-life time of the reaction, trace the shape of the curve using remarkable points. Part 4, half-life time, T-half. 4.1 from the curve concentration of product equal Ft. Definition: half-life time represented by T-half is the time needed for the formation of the half of the concentration of product formed at the end of the reaction, the maximum concentration of product. In order to determine T-half, we calculate concentration of product at T-half equal concentration of product at infinity over 2. On the graph, T-half is the abscissa of the point on the curve of ordinate concentration of product at infinity over 2. Graphically, this is the curve representing the variation of product with time, concentration of product with time. And this is the final concentration of product, concentration at the end of the reaction. The half, we locate on the graph the half of concentration of product at infinity. We locate the point on the curve of ordinate concentration product at infinity over 2. The abscissa of this point represents the T-half, the half-life time. Application 10. Determine the half-life time of the reaction using the curve concentration I2 equal Ft. Solution of application 10. We write first the definition of T-half. T-half is the time needed for the formation of the half of the concentration of I2 at end of the reaction. Then we calculate the concentration of I2 at half-life time is concentration I2 at infinity over 2. We have calculated in part 2 the concentration of I2 at end of the reaction. We find it equal to 20.9. We divide it by 2. We obtain the concentration of I2 at half-life time equal to 10.45 millimole per liter. This is the graph. Now, graphically, we locate the ordinate 10.45 on the curve. We identify the point on the curve of ordinate 10.45. Then, the abscissa of this point is the T-half, in this case equal to 10.8 minutes. Now, according to the graph, T-half equals 10.8 minutes. This is how can we determine graphically the half-life time from the curve of formation of product with time. Now, from the curve representing the concentration of reactant with time equal Ft. Definition: half-life time T-half is the time needed for the disappearance of the half of the initial concentration of the limiting reactant. We should mention the limiting reactant and the initial concentration. Then initial concentration of the limiting reactant. In order to determine T-half, we calculate the concentration of reactant at T-half, which equal to initial concentration over 2. On the graph, T-half is the abscissa of the point on the curve of ordinate concentration, initial concentration, correction. Initial concentration of reactant over 2. Now, on the curve, this is the initial concentration of reactant, and this is the initial concentration over 2. On the curve, the abscissa of this point is the half-life time. Application 11. Determine the half-life time of the reaction using the curve concentration H2O2 equal Ft. Solution of application 11. T1/2 is the time needed for the disappearance of the half of the initial concentration of the limiting reactant H2O2. We are studying the reaction between H2O2 and I- in acidic medium. We have found that H2O2 is the limiting reactant in part 2 experimental study of the chapter 1. Now, concentration of H2O2 at T1/2 equal initial concentration H2O2 over 2 equal 20.9, the initial concentration of H2O2 over 2 equal 10.45 millimole per liter. On the graph, this is the 10.45. We locate the point on the curve of ordinate 10.45. Then the abscissa of this point, which is equal to 10.8 minutes, is the half-life time. Now we write, according to the graph, T1/2 equal 10.8 minutes. This is how we can determine the half-life time graphically from the curve representing the variation of concentration of reactant with time. Now, part 3 of part 4, 4.3, comparing of T1/2 with T infinity. T infinity represents the time at which the reaction ends, the instant at which the limiting reactant is completely disappeared. T infinity then is the end time of the reaction. This is the curve representing the variation of product with time, concentration at end of the reaction of product, and consider this is the end time of the reaction. The half-life time is determined on the curve by locating the ordinate concentration of product at infinity over 2. Then the abscissa of this point is the T1/2. Now, since the rate of formation of a product decreases with time, as we have seen in part 3, then the time needed for the formation of the first half of the concentration of product at infinity, which is T1/2. This is the first half of the product formed at end of the reaction. This part represents the curve represents this part of the curve represents the formation of the first half of the product formed at end of the reaction. It needs a time, this time, which is the half-life time. Then the time needed for the formation of first half of the product formed at end of the reaction is the half-life time. This time needed for the formation of first half is less than the time needed for the formation of the second half. For the second half of product, it is formed, it takes this time to be formed from T1/2 to T infinity. Then, for the same amount of product, it takes a longer time. Why? because the rate of the reaction decreases with time. So that T half is less than T infinity over 2. This is T infinity over 2. T half is less than T infinity over 2 because the rate of the reaction decreases with time. Application 12. The experimental study shows that the reaction, a reaction in general, ends at T equals 70 minutes. This is the T infinity. End of the reaction equals 70 minutes. Choose by justifying among the following propositions the one that corresponds to the half-life time. Is half-life time equal to 35 minutes, bigger than 35 minutes, or smaller than 35 minutes? Solution. Since the rate of formation of a product decreases with time, then the time needed for the formation of the first half of the concentration of product at infinity, which is T half, is less than the time needed for the formation of the second half, then T half less than T infinity over 2. T infinity in this case equal to 70, then T half less than 70 over 2, therefore T half is less than 35. This is the correct answer. Now, part 5, shape of the curve. 5.1 of formation of a product. To plot the shape of the curve concentration of product equal Ft within the interval of time 0 t, we should determine the following characteristic points or remarkable points. First, initial point 0, 0. If initial concentration of product equals 0, sometimes the initial concentration of product is bigger than 0, but in most cases it is 0. The second point, we have located the first point 0, 0. Second point is the half-life point of coordinates T half and concentration of product at infinity over 2. We locate the second point. This is the concentration of product at infinity over 2, and this is the T half. The intersection between these two values is the half-life point. We locate the half-life point on the graph. The third is not a point, it is a maximum limit, which is the concentration of product formed at infinity. The curve tends to a horizontal asymptote of ordinate concentration product at infinity. Now, the shape of the curve should pass through the points, initial point and half-life point, and tends to a horizontal asymptote, which is the concentration of product at infinity. Then this is the shape of this curve. But remark, we should not exceed the given final time t. For example, if this is the final time t, then the shape of the curve should not exceed this time. We should not complete drawing after t. (5.2) of disappearance of the limiting reactant. To plot the shape of the curve concentration reactant equal Ft within the interval of time 0 t, we should determine the following remarkable or characteristic points. Initial points 0, initial concentration of reactant. We locate this point 0 and initial concentration of reactant. Second point is the half-life point T half and initial concentration of limiting reactant over 2. for we draw the shape of the limiting reactant. We locate this point on the graph of coordinate T half and concentration, initial concentration over 2. This is the half-life point. Now, the minimum limit, the curve tends to a horizontal abscissa, which is a horizontal asymptote, which is the axis of abscissa. Why? Because the concentration of limiting reactant at end of the reaction equal to 0. Then it tends to 0 the curve. The shape of the curve becomes like this. It passes through the initial point and the half-life point and tends to 0 the axis of abscissa.